Good morning, everyone. I hope you're having a great day today and that everything is going well with you. I hope that you're all staying happy and safe and healthy, and that hopefully that your A day is going well. Now, we're moving on into chapter 3, which is about the Earth and its climates and basically all the processes that help the Earth kind of like establish weather patterns and climates and different things. And one of the first ones that we're going to talk about is, of course, the sun, which is a huge factor on creating our climates. So the sun is the brightest star in our sky. Part of that is because it's literally the closest one. The other stars are millions of miles away, even though the sun is too, but triple or quadruple that distance. And you have at least some idea of how far away other stars and galaxies are. Now, the sun is a major factor in creating our climates, while it's composed of hydrogen, helium, and other gases, it rotates on an axis at about the same angle as the Earth does. The Earth is not straight; it is like kind of tilted. We can't tell because we've always been used to it. So, when you think about it, you've never actually walked straight in your life. You've always been at an angle, but that's just like gravity and other forces has kind of tricked you into thinking that you are not actually curved or like standing sideways. But only a tiny fraction of the power generated by the sun reaches the Earth, which is probably a good thing because if we got like a little bit of it, we'd be burning up and everything like that. Now, there are two things. Like when you hear about climate and weather, you have to realize they're two separate things. Weather is actually your condition of the atmosphere in a certain place at a specific time, meaning that on a single day is weather, or even just over a week is weather, because it's a very specific time frame. And so weather would be like a thunderstorm rolling in, or the hot day, or a cold day, or a snowstorm, or a hurricane. These are very specific weather events that are happening at any given time. Whereas climate is a long-term typical weather pattern. So the type of weather that we receive continuously determines our climate. So in Louisiana, we experience a lot of hot days. Our normal weather is hot and humid, at least in the summertime. In the winter, it's cool and humid, though that makes it seem colder. But with climate we experience, we have a hot, humid climate because our typical weather pattern is hot and humid, if that makes sense. And as the climate of an area is determined by many things, but the most important is the Earth's position in relation to the sun, and I'll explain more about that in just a second. But just so you can kind of get an idea of United States climates, we have here, our climate typically runs pretty hot. Our minimum temperature is usually 20 degrees, which is not much. That's pretty low. The further south you go, the warmer it stays. And so our area is typically pretty warm. Now, as far as the actual maximum temperature, it's hard to tell here, but it gets pretty hot. And again, that's also humidity as well. So the further up you are in distance away from the equator, which gets the most sunlight, the cooler your temperatures are going to be. I'll show more on the next slide. Now, there are many climate zones throughout the Earth, and each of these has, somewhat different types of climates. So if you look here in the little green area, we actually probably fall under more of a tropical style, which seems kind of crazy, but that means it's very hot and humid. Whereas a little bit further north, they have warm, temperate, humid, meaning it's not too hot, not too cold. It's kind of nice. So, and then as the further in different directions you go, if you look down here in South America, close to the equator, most of these areas have a tropical climate of some kind. It means they're very warm and very humid. Now, the Earth is tilted at an angle of about 23.5 degrees. And because of the tilt of this axis, not all places on the Earth receive the same amount of direct sunlight at the same time, meaning that some places just like they don't get that sunlight, so they're either cold, they're cooler typically, and they have different temperatures. Now, the Earth travels in an orbit around the sun. This should all be pretty, like you should all know this by now, I would hope. Like you covered this in elementary or middle school. And one trip around the sun for the Earth is 365 days approximately. So that is a year. So it takes 1 year for the Earth to travel around the sun. And our seasons are caused by the Earth's revolution around the sun and the Earth's tilt. So where our location is at a given point will determine what season we're in. And the seasons are separated by what is known as the equinox and the solstice. And the equator is kind of like the one that divides for the equinox. So because the equator divides the Earth into two hemispheres, north and south, like when one is experiencing winter, the other is experiencing summer because of the Earth's tilt and the way it's rotating. So to give you kind of an example here, okay? So this is North America, right? Okay? So here you're different. So you have the equator right here. Well, this is at the vernal equinox. This is when we have spring, okay, the start of spring. So we're getting a lot more sunlight in the northern hemisphere. Whereas on the bottom half of the world, they're getting further sunlight. So in the southern hemisphere, they're not catching as much. So in the summer solstice, which is when the northern hemisphere is getting the most sunlight, and that is why it's hotter. So the further, so when the Earth is coming back around by the wintertime, because of the shape of it, the southern hemisphere is getting the most sun and the northern hemisphere is not. Now, the line of latitude at 23.5 degrees north is called the Tropic of Cancer. This is the northernmost latitude on Earth to receive the sun's direct rays, meaning it's the one that's going to catch the most sunlight at any given point in the north. Then the Tropic of Capricorn is the same thing, the southernmost latitude to receive the sun's direct rays. Okay, so here are your tropics, and this is why we call them the tropical region. This area here is the reason we call it the tropical area, because they are situated between the tropics of Cancer and Capricorn. And again, you can see it here. They get the most direct rays at any given time. Now, the tops and bottoms of the Earth are the North and South Pole, and they're at the ends of the axis. And each one receives continuous indirect sunlight 6 months out of the year, which means they also catch a lot of time period where there isn't indirect sunlight or direct sunlight. So meaning that they have long stretches of day and night. So when one receives continuous sunlight, or what's known as a midnight sun, the other receives little to no sunlight, meaning it's perpetually dark. When there are equal hours of daylight and nighttime, that is an equinox. So when the spring and fall come in, the amount of daylight and the amount of night hours are the exact same, whereas in the winter, nights are longer, days are shorter. In the summer, days are longer, nights are shorter. And again, this is all based on our tilt of the axis, 23.5 degrees. Now, another factor that creates climates is the greenhouse effect. This is where part of the sun's radiation passes through the atmosphere, and kind of like a greenhouse, which is meant to capture those sun's rays and then keep the heat. It keeps the heat from escaping back into space too quickly. So it bounces off the surface, and because of the atmosphere, it kind of keeps it in. The problem with the greenhouse effect is that this is a natural occurrence. It itself is not a bad thing. But when we, humans have actually altered Earth's atmosphere by burning fuels that release carbon dioxide and other greenhouse gases in the atmosphere. And so that has made it to where we keep more heat than we're probably supposed to, which leads to climate change. And then when you also factor in things like forests being cut down because they absorb carbon dioxide, and that rise in carbon dioxide levels have coincided with a rise in global temperatures, it has made a lot of scientists kind of wonder if maybe the rising CO2 levels have been part of the cause. This is known as global warming, but now the term is more used for climate change, which means that climates around the world are changing. What that means, though, is still up for debate. Okay, that's the end of today's lesson. I hope, that you were able to watch and pay attention. If you have any questions, please don't hesitate to email me, and I hope to hear back from y'all, and I can't wait to see y'all tomorrow. Thank you.